So again, understand that they are 5 to 7, which you'll hear that definition. But there are certain ones that if they are not there, that they absolutely won't open. I kind of won't go into it, but just know that everyone has to have that. Since we already talked about projections, there's a .prj file that if you ever give somebody a shape file, which are those files, and it doesn't have that, it won't know where in the world it is. So that one is very critical, because sometimes they will surprise you and still open, but everything in GIS, as we've been going over for the last 2 weeks, has to have a spatial reference, right? We've kind of drilled that into to what that has to be there. Okay, on the flip side of that, file geodatabase. Somebody give me, and again, these are just talk. I'd rather you not try to give me scientific definition. Talk me through it. Give me layman's terms, because if you could tell me in layman's terms, I know you understand. What's a file geodatabase? There's no wrong answer. Just say it, and if it's right, I'll commend you. If it's wrong, I act like you didn't say it.
Spatially referenced data set, a database with geospatial reference.
Right. So don't get caught up on the file geo. I mean, we all understand what a database is, right? So basically, we understand Microsoft Access or something like that. A database is that big list of tables that you put all into one, and now have this big inventory of tabular data, and it's now a database. Same principle. It doesn't need to be, you don't need to think about it any more as far as the actual purpose of it, any more in depth than that. It's these tables that are put together in one big format, and it's spatially enabled. So it's this tables of points, tables of polygons, tables of lines that's in a database, the same way that you would think of a database. Why that's important to understand the database part of it is because right now we're only working in file geodatabases. Another thing to understand about that is a file geodatabase, for all intents and purposes, is like a folder. That's why it's called like a file folder of these tables and polygons and points and lines. When you become an actual GIS professional, which all y'all have a chance of doing, the database part gets more significant, because now you're going to be working in SQL Server or Oracle or a real enterprise database, because hundreds of people might be working in that database, and it might be an international database, or like a database for the city of Jacksonville is massive to have all that information. A file geodatabase won't work, but so just know that a file geodatabase kind of builds up to those SQL Server databases, but a file geodatabase for smaller things is definitely more easier to use, because it's a folder, and it's easy to put on a flash drive, and there's no connection to the database and all that kind of stuff that you would do for a SQL Server database. What about feature class? Yes, a feature class and a feature layer are the same thing. Don't go to drinking all this caffeine trying to figure that out, because when I tell you why nobody couldn't tell me that they're the same thing, it turns into a layer once you put it into the map, and gets those layer properties, which is all that symbology and what it looks like and how it's labeled and all that. But in terms, it's still that same feature class. The feature class when people say feature class, they're thinking about it within the file geodatabase. When they think of feature layer, they're like, okay, you can put it in a map and you're actually using it for a visual. Only difference. So those are synonymous. Don't ever go caught up on that being different. What about feature data set?
That's the data that builds the feature classes.
So there's a hierarchy, right? There's the file geodatabase, GDB. Oh, I wish they make these clean these boards. I don't know whether y'all can see that. So there's this file geodatabase, and it can go down to this data set. So the reason you would make a data set is I have all the information for the city. That means parks, that means electrical, that means public works, that means all their sidewalks, all this stuff. Would it be advantageous for me just to throw all that in there, then I gotta look through 50 different layers just to find where FSCJ is? Or could I make a schools data set and put all my schools there? Could I make a sidewalks data set and put all my sidewalks in there? Could I make a parks data set? It's just a way of organizing alike things versus having 100 different feature layers out there. You got to try to figure out what is what. Because if I said, if you're not from Jacksonville and I just had a layer called FSCJ, what would that mean to you? Nothing. You're not from Jacksonville. That acronym doesn't ring anything to you. But if I had a layer called FSCJ that was in my school's data set, what at least does that tell you? That it's a school. Then I can drill down from there and figure out what kind of school and does that fit what I'm trying to do. So it's just a way to organize data. It's not a mandatory, but again, people have a short attention span, so we're supposed to, as the GIS professionals, make it easy for them to find our data. Features. What do you think of when you hear the term features?
It's like a defined object, or it's like a discrete thing in the data that you want to represent.
So features is a thing. That's it. Just think of features as a thing. If I add a point to a map, it's a point feature. If I add a line to a map, it's a line feature. Feature is just a point, line, or it's that thing, that point, that piece of data is a feature. So remember when we checked our status bar at the bottom and we selected something and it said 2 selected features or 1 selected feature? All that meant is that we selected a point or a line or a polygon in the map. So once something is in the map, it's a feature. If I click on FSCJ in my school's data set, I clicked on a feature. So it's a thing, a point, line, or a polygon. And I just answered the next thing, the data types. We know that our GIS takes points, lines, polygons, and what's that other one? Raster, which is your imagery or your aerials. All of those are synonymous for the same thing. There are other things when you get into 3D and all that kind of stuff, but that's far out of scope, and to be honest, it's an acquired taste, and not many people at this point feel the need to do it. Even now that drones are making, getting in drones is a big business, being able to map what they come up with for those drones. But even that's still probably gonna fall into either imagery or points, lines, and polygons when it's done said and over. They won't want to do a 3D rendering of it. Most people won't. So we did a layout last week. So there were certain things that I want you to remember that always need to be a part of a layout. I just put the things that we worked with last week, but there are a couple of more. We'll talk about them we'll probably talk about them towards the end of the night. So that's that north arrow. You always need to know where north is. That's that scale. That scale matters to the point of what area are you showing and how can I use this map to measure how to get from there to here using your map. And it needs a title. There are other things that it needs. You always have to put an author of a map and a couple other things like that. But we'll talk about that because we're going to make another layout tonight for you guys to submit for your assignment. I want you to be familiar with the term symbology, and we've done some things with symbology as far as changing how things look, changing the symbol of things, and be familiar with the fact that you can make everything one solid color, and you can also use the data in the map to say, I want all parks to be green, all water to be blue, all, as we did with one of the layers from, I think, week 2. So be familiar with that term symbology. Map package versus project package. What's the difference?
Was map just you're only able to see the one map and the data with that one map, and then the project package, it shows the several?
You onto it. You onto it. So to build on what you just said, that project package is going to be include the data. That map package is only gonna reference the data. So remember, it had to be in that C student, and if it wasn't in there, it got those broken, exclamation points. Because it didn't see it where it thought it was supposed to see it. When you give somebody a map package, it's saying, it's automatically thinking that they have the data exactly in the same folder that you have the data. And if not, it doesn't know what to do. When you send it in that project package, you're sending the data along with it, so it doesn't have to look for it. It's not referenced, it's telling it where it actually is within that project package. And then we talked about projections. So what's the purpose of a projection? So remember, we went through, and a couple of them were unknown, and then a couple of them was the NAD 83, and then the WGS, the World Mercator. What is that telling? What is it? Yeah, the coordinates is telling where in the world are you? Because the North America, South America, where are you in related to the equator? Are you East Coast, West Coast? The world is curved, right? We learned all of that, and that's very specific. Me and Alex was just having a conversation about survey grade. It gets very minute to knowing where you are in the world when you're trying to get something that's 3 inches off the ground. Sea level and all kind of things come into that. So these projections put you where you need to be. And when you're sharing data internationally, the coordinate system is different in China than it is in North America for obvious reasons of location and where they are on the earth. And we talked about, I want you to definitely understand the hierarchy of where you put data in these project paths. And I just kind of talked about that broken exclamation point to when when you're referencing a geodatabase, but that geodatabase is not in that path or not in that same folder, you can't find it. But if you make a project in a folder that has a file geodatabase in it, what happens? You can access that geodatabase, right? Because it just knows that it's all in the same folder. So that folder hierarchy is very important about how ArcGIS Pro, accesses data, especially when you're doing file geodatabases. When you make a new map and put it in a folder that has 15 geodatabases in it, when you go to your catalog pane, you can see all 15 of those geodatabases, just because you put that map in that same folder with the rest of them. And sometimes that's work smarter and not harder. Sometimes that's all you have to do. Instead of putting that map in a different location and bringing all those databases in, just save that map in the same place as those geodatabases, and they'll all just show up. Because it's going to access that folder and everything in that folder. All that makes sense. Now, like I said, I'm not expecting you to be able to write definitions. I'm expecting you to have recognition of these terms and be able to say if somebody told you that a feature is a picture, you'll know that a feature is a point line or a polygon in a map. I need you to be able to say what it's not more than what it is, because at the end of the day, that's going to dwindle it down to your understanding. So let's go ahead and, if you haven't, go ahead and make your C student folder and put your chapter 8 in there.